Hi everyone. My topic is readers writers problem. The readers writers problem is a classical problem of process synchronization. It relates to a data set such as a file that is shared between more than one process at a time. Among these various processes, some are readers which can only read the data set. They do not perform any updates. Some are writers can both read and write in the data sets. The reader's writer's problem is used for managing synchronization among various reader and writer processes so that there are no problems with the data sets, such that no inconsistency is generated. There are some points about the introduction of reader's writer's problem. The multiple reader-writer activities can run simultaneously. At any time, a reader activity may wish to read data, or a writer activity may wish to write or modify the data at any instant. Simultaneous reading and writing to the data can cause inconsistency. Therefore, to avoid this situation, a set of rules is followed. Any number of readers can access the data simultaneously, but during the time a writer is writing, no other reader or writer may access the shared data. There is a picturization view of sharing of data. Here, readers can only read the data set, they do not perform any updates, and writers can both read and write. For a more understanding, we can consider an example or a situation. Consider a situation where we have a file shared between many people. If one of the people tries editing the file, no other person should be reading or writing at the same time. Otherwise, changes will not be visible to him or her. However, if some person is reading the file, then others may read it at the same time. Precisely in OS, we call this situation as the reader's writer's problem. The problem parameters are: one set of data is shared among a number of processes. Once a writer is ready, it performs its write. Only one writer may write at a time. If a processor is writing, no other process can read it. If at least one reader is reading, no other process can write. Readers may not write and only read. There is another picturization that readers have priority and another with writer have priority. In the first reader or writer problem, reader priority, no reader will wait even if a writer is waiting, and there is a writer starvation possible, and semaphore solution is the role to this. And for writer priority, no new readers are allowed once a writer has asked for access. Solution can be implemented using monitors. Now we are going to discuss about what is a semaphore. A semaphore mutex is used to ensure mutual exclusion when a semaphore is a non-negative integer and it is denoted with this the symbol S. There are two types of semaphores. First one is binary semaphore and second one is counting semaphore. The values of binary semaphore lies between 0 and 1, and the values for counting semaphore are starting from 1, 2, 3 and etc. And there are two functions which used to modify the values of semaphore variables. That is, first one is wait s and 2 is signal. There are some solutions using semaphore. Here we have to use three semaphore variables for solving this problem. First one is mutex initialized to 1, that binary semaphore. Write initialized to 1, binary semaphore, and read count initialized to 0, counting semaphore. The mutex is used to lock critical section for both readers and writers. WRT used to block the writers from entering the critical section, and read count helps counting the number of readers in the critical section and permits the writer to enter when it becomes 0. Here's the structure of a reader process. Here the mutex semaphore ensures the mutual exclusion, and WRT handles the writing mechanism and is common to the readers and writers process code. As soon as read count becomes 1, wait operation is used on WRT. This means that a writer cannot access the object anymore after the read operation is done. Read count is decremented. When read count becomes 0, signal operation is used on WRT, so a writer can access the object now. And there is a structure of writer process. If a writer wants to access the process, wait operation is performed on WRT. After that, no other writers can access the object. When a writer is done writing into the object, signal operation is performed on. So the basic structure of a solution as a reader, there is 3-1, that is wait until no writers, access database, check out, wake up and waiting writers. And in case of writer, wait until no active readers or writers, or access database, check out, wait up, waiting readers or writers. This is all about the topic readers writers problem in OS. Thank you.